Welcome to a new part of the ISM Statistics 1 exercise. This time with an exercise on continuity. Let's take a closer look at the exercise. Decide whether the characteristics below are continuous or discrete. Gummy bears per bag, amount of tea in a cup, number of students at the ISM, final mark, length of a movie, recharge time of battery, money in a savings account, number of holidays in a year, weight of a bar of chocolate, and time. Let's move to solving this. Let's start with the gummy bears per bag. Well, obviously there's always like one gummy bear, 2, 3, 4, 5 gummy bears, and not like 0.8978429 gummy bears. So this means the amount of gummy bears is discrete. Now we can move on to the next part, the amount of tea in a cup. This is something we might call semi-continuous or quasi-continuous, because on the one hand it's discrete because we can directly see say this amount, so this many gram, and it's always like this many parts which are there. On the other hand, even weight and grams can be considered continuous, so this is rather somewhere in between, so it could be called semi-continuous, or as we call this here, simply continuous if we work with the weight of the tea. And then we have number of students at the ISM. Well, obviously we can't have like half a student, so this is a typical example for discrete. Something similar applies for the final mark, even though there might be like in-between steps. We don't only have like 1.0, 1.3, 1.7, but something in between. However, it cannot get very detailed, so this still would be discrete. However, if we consider this in some context where we want to calculate like the average, we can still work with this, because theoretically it's always possible to break it down even further. So we might call this, instead of discrete, quasi-continuous. And then moving on to the next one, the length of a movie. This could be theoretically divided in smaller and smaller and smaller parts. Well, usually you only say this many minutes or this many seconds, but you could theoretically break it down even more. That's why we call this here continuous. Something similar applies for recharge time of a battery. Maybe you only have like different lights showing you how much you already recharged your battery, what the power level is, or in your mobile you see like this many percentage. However, it's more or less a flowing process. That's why we could call this continuous as well. Money in a savings account, that's a little bit different. Why is this different? Because even if you break it down, usually savings account are having like the smallest unit. For example, Germany, we would go working only at the cents level. So the smallest unit would be 1 cent. So that would make this variable, this characteristic, discrete. However, usually you can work with this in a way as if it were continuous. Therefore, this is again an example for quasi-continuous characteristic. Then we have the number of holidays in a year. Number of holidays, it's like a very specific number. It's only like 1 holiday, 2 holidays, whatsoever. It's nothing like, yeah, I'm spending like 3/4 of a holiday somewhere. Therefore, this is typically discrete. Then second to last, the weight of a bar of chocolate. Well, usually when you buy a bar of chocolate you get something like 100 gram or half a kilo of something. But it could be broken down even further. Weight, we argued this with the T already, can be broken down as much as someone likes, so therefore the weight here is also continuous. Bringing us to the last part, to the time. Time as weight can be broken down as much as someone likes, making this as well continuous. One might argue again, yeah, but my watch only shows this and this. Yeah, but this is basically limitations of the watch. This is not due to the variable of time. Therefore, time again is like a continuous characteristic, continuous variable. Leading to us having concluded this exercise, and I hope all of you enjoyed listening and learned something. Then, until next time, see you and goodbye.